Hello everyone. So this is a question from JEE Advanced 2026 paper 2. The correct statements regarding sugars is okay. So there are a few options given to us. The chapters involved is biomolecules. The first option is on treatment with HNO3, gluconic acid is oxidized to saccharic acid, whereas glucose is not oxidized to saccharic acid. Okay. So the open chain structure of glucose is CHO, CHOH, 4 times, then CH2OH, right? So it contains, so this is our glucose, and it contains one aldehydic group. It contains four 2-degree or secondary alcoholic groups. It also contains one 1-degree or primary alcoholic group. And gluconic acid looks something like this. We have COOH, CHOH4, and CH2OH. So this is my gluconic acid. On oxidation with concentrated nitric acid, both glucose, that is this guy, and gluconic acid, that is this guy, give the same dicarboxylic acid known as saccharic acid. Okay, that is with respect to reactions, CHO, CHOH, 4, CH2OH, HNO3, oxidation, glucose, COOH, CHOH, 4, CH2OH, gluconic acid, HNO3, oxidation. I'll be getting COOH, CHOH, 4, COOH. This is my saccharic acid. Okay. So this reaction, that is glucose reacting with HNO3, confirms the presence of one terminal 1-degree alcohol group since we are getting saccharic acid. Okay. Therefore, the acid, that is HNO3, oxidizes both the terminal aldehyde and the terminal 1-degree alcohol group into COOH and COOH. So therefore statement A is incorrect. Both gluconic acid and glucose upon treatment with HNO3 is oxidized to saccharic acid. Okay. So A is incorrect. Now coming to statement B, which says that fructose gives a positive Felling's test because it isomerizes to glucose and another aldohexose in the presence of Felling's reagent. Okay. So we know that all those carbohydrates that reduce Tollens reagent or Felling solution are called reducing carbohydrates, and all the monosaccharides, whether aldoses or ketoses, are reducing sugars. Important. All monosaccharides, now whether they are aldoses or ketoses, are reducing sugars. Okay. Now aldoses are those monosaccharides which contain the CHO group in open chain form. For example, D plus glucose, and D plus glucose looks something like this. Giving numbers 1, 2, 3, 4, 5, 6. Okay. And ketoses are those monosaccharides which contain the C double bond O group in the open chain form. For example, D minus fructose, okay, which looks something like this. CH2OH, C double bond O, COH, H, CH, OH, CH, OH, and CH2OH. Giving them numbers 1, 2, 3, 4, 5, 6. Now, a doubt should come to your mind. How come ketosis, like D minus fructose, this guy, containing C double bond O group, are reducing? Because tolens and Fehling solution are weak oxidizing agents. So they should act only on aldoses, for example, D plus glucose containing the CHO group. Then how are ketoses reducing? Okay. So the answer to this is we have observed that when glucose is treated with a dilute solution of alkali, it undergoes reversible isomerization to form an equilibrium mixture of D-glucose, D-fructose, and D-mannose. Okay, so when glucose is treated with dilute solution of alkali, it undergoes reversible isomerization to form an equilibrium mixture of D-glucose, D-fructose, D-mannose. Okay, that is, with respect to reactions, I can write CHO, CHOH, CHOH thrice, CH2OH. This is my D plus glucose. I will also have CHO, COH, H, CHOH thrice, CH2OH, which is my D mannose. I will also have CH2OH, C double bond O, CHOH thrice, CH2OH, which is my D fructose, D minus fructose. Okay. So you can see when we treat glucose with dilute solution of alkali, it undergoes reversible isomerization to give me an equilibrium mixture. So I will have all three of them, D-glucose, D-fructose, D-mannose. Okay. So the same mixture, the same equilibrium mixture, that is this, is obtained even if we start with D plus mannose or D minus fructose. Okay. So let's say that, instead of glucose, I'm taking fructose here, and I treat fructose with dilute solution of alkali. It will also undergo reversible isomerization, and I will get the same equilibrium mixture consisting of D-glucose, D-fructose, and D-mannose. So because of this isomerization, fructose in the presence of OH minus, and this OH minus, it is present in Tollens or the Fehling solution. So this comes from the Tollens reagent or the Fehling solution, forms an equilibrium mixture. So it undergoes reversible isomerization. It will give us an equilibrium mixture of D plus glucose 2. So which will reduce the Tollens reagent or the Fehling solution. So it is not actually the fructose, but since we are treating fructose with OH minus, it is undergoing reversible isomerization to give us an equilibrium mixture which consists of glucose, and this glucose reduces the Tollens reagent or the Fehling solution, right? So therefore statement B is correct. Fructose gives a positive Fehling's test because it isomerizes to glucose and other aldohexose like mannose in the presence of Fehling's reagent. Okay, so B is correct. Now coming to statement C. Statement C is invert sugar is an equimolar mixture of D-glucose and D-fructose formed after hydrolysis of the corresponding disaccharide. Okay, so sucrose, which is also known as cane sugar, having formula C12H22O11 on hydrolysis with dilute acid or enzymes like invertase or sucrase gives an equimolar mixture of D plus glucose and D minus fructose. That is, with respect to reaction, I can write C12H22O11, which is sucrose, plus H2O. In the presence of dilute acid HCl, I'll be getting C6H12O6, which is my D-glucose, plus C6H12O6, which is my D-fructose. Okay, so sucrose is dextrorotatory, turns the plane of the plane polarized light towards right, and this mixture that we have obtained of D-glucose and D-fructose is levorotatory. So it turns the plane of the plane polarized light towards left. Since hydrolysis of sucrose to an equimolar mixture of D plus glucose and D minus fructose is accompanied by change in sign of optical rotation, because it's initially it was dextro and the final mixture is levo. This overall process is called inversion of sugar. Okay, so this process is called inversion of sugar, and the equimolar mixture obtained, that is this mixture, as a result is called invert sugar. So this mixture is known as invert sugar. Okay, so therefore statement C is correct. Coming to statement D, so we know that sucrose reacts with H2O in the presence of HCl to give me D-glucose and D-fructose. Okay, so the specific rotation value of sucrose is 66.5 degree, plus the specific rotation of D-glucose is alpha is equal to plus 52.5 degree, and the specific rotation of D-fructose alpha is minus 92.4 degree. Okay, so to calculate the specific rotation of invert sugar, that is for this mixture, we take the weighted average based on concentration of individual components. Okay, so therefore we have to use the formula alpha mixture is equal to F1 into alpha 1 plus F2 into alpha 2 plus goes on. Okay, where F1, F2, Fn is the fractional concentration of each component. Fn in general is the fractional concentration of each component, and alpha 1, alpha 2, alpha n in general is the specific rotation of that pure component. Okay, since in invert sugar we are obtaining a equimolar mixture, so this mixture is equimolar. That means the number of moles of D-glucose and the number of moles of C6H12O6, that is D-fructose, is same. So since in invert sugar we are obtaining a equimolar mixture, therefore their percentages are 50% and 50% each. So therefore their fraction will be 50 by 100, that is 0.5 each. Okay, so therefore the specific rotation of the mixture, that is alpha of the mixture, will be equal to F1 will be, for D-glucose the fraction is 0.5 and its specific rotation is, as we have written, plus 52.5 degree, plus the fractional concentration of D-fructose is also 0.5, and its specific rotation is minus 92.4 degree. Okay, so when you do this calculation, we get specific rotation of the mixture as minus 19.95 degree. Okay, in statement D they have mentioned that specific rotation of invert sugar is minus 40, which is not correct. The actual value is minus 19.95 degree. Okay, so statement D is incorrect. So therefore the correct statements are B and C. Okay, thank you.